All right, I'm displaying, this is modern versus old school and AppSec journey. Apparently, from a code security perspective, right? No one cares about AppSec as much as like IoT. That's cool. Yeah, I'm super excited to be here. Introductions, first of all, that's me on the screen, or you can look over here. Either way. I'm Seth Law. I am the founder of Redpoint Security. I've been in the security industry for a number of years, doing mainly code security and application security in that time. I actually started my life, or my security life, as a developer at iOmega. If you remember the zip drive people, those of you that actually had one, right? Like, I was not responsible for the click of death. I was on the web side of things, so you can blame the engineering, portion for that, not me specifically. I co-host a podcast called Absolute AppSec with my friend Ken Johnson, CK Tricky. He and I have been running that for about 5, 6 years, 7 years at this point. And all we do is talk about application security topics, right? Obviously, Absolute AppSec, huh? Duh, right? But realistically, it's breaking down like how we secure code, how we find vulnerabilities in code, and how we can help, right? Like getting people into application security, specifically developers and others, right? As they get into this space. So to start off, how many people here are developers or application security people? Awesome. Sweet. Well, I'm happy to have you because, this is intended for you, obviously. As far as what application security is, or what we consider that to be, if you're a developer, you're probably very familiar with this, but it's realistically just securing an application and its data against compromise. And how we accomplish that is done through various mechanisms. So it's custom code, library, process, person, tool, technique, something that affects the security of the application, right? We've got things like SAST and DAST tools that we use nowadays, so dynamic analysis, static analysis, SCA tools. We're seeing a lot, I didn't necessarily add LLM into this, right? That's the new hype thing. I probably should have. But at the very least, right, like that's what we're starting to use, and that's what's starting to help us secure code. But that doesn't necessarily mean that we didn't come from somewhere. That's the whole purpose of this talk. Like, how did we actually get to where we're at in the industry? And are we making progress? So this idea of modern, like the modern tools, the modern DevSecOps processes, security operations, everything that we use, these SCA and SAST tools, like we've come a long way, right? That is the story that we tell ourselves, right? From a modern perspective, we have things like the security software development lifecycle. We've got like all these techniques that we use. We're pushing left and, designing software securely. We've got frameworks that are built securely, authentication authorization providers, bug bounties, tools, like all this stuff. Whereas like it comes with this picture that the old school was this lack of security controls, that maybe there was just a username and password, but we didn't have an understanding of security. There were all of these tooling deficiencies. What I'm getting at today is that story that we're telling ourselves is actually wrong. And this comes from the experience that I've had over the years, right? Like there has been a lot of research that's been done over, since basically the 50s and 60s in the same techniques and the same vulnerabilities that we see nowadays. The main one that I wanted to talk about was this report from 1970. The research was done in 1969. It's known as the Ware Report. It was the report of Defense Science Board Task Force on Computer Security, right? So a bunch of these guys that were, smart developers went and basically tried to decipher what security should look like in this new realm of computing at the time. And the controls that they came up with are what was recommended for the Defense Department and DoD installations and, the government in general on how to secure a system. And it put forward a number of recommendations and guidelines that should be followed, right? One of the things that they tried to do initially was like, hey, we're trying to identify what is the most risky situation that we can run a computer or an application in. And it calls out this specific security control situation. Time sharing, multi-access system, geographically distributed users, and systems that are processing sensitive information. Now, what does that sound like to you? Is that not the internet? Like, is that not what we operate in nowadays? Right. And this report is a fascinating read coming from the security controls that we look at and think about today because of this. Right. And this is back in the day when like they couldn't even make two computers really talk to each other. Right. Like early days of the ARPANET, the DARPANET, like, and they're already identifying these sorts of controls as something that we should be concerned about, right? This graph is taken directly from the report itself. So these are the vulnerabilities that they call out. Like, I mean, these should be fairly familiar to you in the security space. Accidental disclosure, like disclosure of sensitive information. We see this. Deliberate penetration, like someone's actually red teaming us or attacking us, active infiltration, passive subversion, physical attacks, right? And the more that I look at this chart that they've come up with, this graph, the more I think, man, like they were doing threat models back in the 70s. They just didn't call it a threat model, right? They were coming at it from, hey, I'm a DOD, or I work at the Defense Department. We're already thinking about active threats like physical threats, and they were pushing that onto the virtual world. And we continue to do that, right? Like we talk about pushing left, we talk about threat models, we talk about physical attacks versus, the cyber attacks that are coming in. And they've already got all of this this has already been identified. And remember, this is 1970 that they're doing this. This is very innovative research. And even nowadays, if you were to pull this out, you would consider it to be, right, like this could be a blog post coming from the Defense Department today, which is, I mean, it's just fascinating to me, having been in there. Some of the conclusions that they made, right? Like you don't necessarily need to read through this, but the two interesting ones here, right? First of all, providing satisfactory security controls in a computer system is in itself a design problem, right? We have not pushed left far enough in order to solve this. Like security by design is what they're recommending. And then again, these are conclusions. And then it is unwise to incorporate classified or sensitive information in a system functioning in an open environment unless a significant risk or accidental disclosure can be accepted. Right? We've seen this over and over again with all the breaches that are out there, right? Like unless you can accept the risk of, I don't know, like all of your credentials being exposed, then maybe you shouldn't operate in a open environment with sensitive data, right? Where am I going with this, right? There are a number of old school exploits and problems that I've seen through the course of my career. There's a reason why they call this an AppSec journey, because at the time, and as I was finding these things, I thought it was, like this is fairly innovative. There's like, people haven't necessarily thought about this, but really not much has changed. And that's what I'm proposing here is, yes, we are making progress, but there, not much has changed over time. So if we start from old school exploits, right? Go back to 1992. There's a, there's a system, 1992. I'm in, high school, and there is a system that the district decided to implement to let people know about absences, or send notifications to parents. If any of you have kids in school, you're probably aware of this, right? Like when my kids miss a day of class, I get a text, I get a phone call, I get an email. Hey, they've actually missed something. This is early iterations of that. They're notifying you. But it was a voicemail system that they had implemented. You could call in, you could press 1 for announcements. It would track your number. No, it wouldn't track your number, but you could, there was a number of different things that you could do when you dialed into the system. It was just like a voicemail box, right? But it was the same system that would call out and notify us of absences on a daily basis. Now, being enterprising, we didn't necessarily, want our parents to know if we were skipping classes, because why would we, right? So there I am, right? This is me at 16, 15, rakishly good looking, obviously, has not changed. No, never mind. But basically what we have here is a phone system, like an environment that's running with anonymous access, because people can dial in. Remember, there was no caller ID at this point, right? It was the phone system was an anonymous system, and it allowed for interaction. So you could press 1 for announcements, 2, nothing came back, 3, nothing, 8 would repeat the menu. I'm like, oh, that's interesting. But what happens when you press the star key? Oh, please enter the administrator passcode. This is amazing, where there's 3 or 4 of us that are enterprising, and we figure this out. Okay, this is early 90s. How long do you think this administrator passcode actually was? Yeah, 4 digits. Of course it was, right? So what we did, because we wanted to figure out what we could actually do, is we broke up the number. There was 4 of us, right? And we just took all the possible combinations. There's 10,000 of them. And we spent one afternoon and we went through all of those possible combinations. I think after about 4 or 5 attempts, it would actually disconnect you. So you'd have to call back into the system. But again, it's anonymous access. We're just going to go do, 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 do. And eventually we figured out, oh, it's 5642. Now, it was Logan City School Districts. We should have tried this first, right? But we didn't. We got to it eventually. And at that point, it gave us a new menu, a bunch of different things that we could do. We could add announcements, right? So when somebody else would call in, it would actually show them. And we could reset the administrator passcode, which we considered, but we didn't want them to know that we'd do that. Or it would restart the system. Now, remember, this is the same system that was dialing out to parents on a daily basis, and the secretaries would load the data in at about half hour after school had closed for the day, so that it could make its calls for the night. But where does that data go? It goes into memory, which is not stored on disk. And if you restart the system, say at 350, guess what it doesn't do anymore? Doesn't make any more calls, right? Yeah, we used this for about 3 years, like the entire time I was in school. They reset the password on us a couple of times. But the fact that we weren't using it every day, it was only when people knew that we wanted, or that we skipped, that we would actually reset it. I think they thought the system was just, faulty or something like that. Like that, dang it. And sometimes they would actually reload things in after, so we had to play a few games. But okay, so that was 1992. You kind of expect this sort of thing to happen, right? Again, like old school exploits and abuse of those sorts of voicemail systems was a fairly common thing back then. You look at some of the old school, hacker zines and stuff. That's Frack, right? Would go into things about this. Password guessing, but this has not changed, right? You look at modern systems nowadays and we'll see something very similar, right? Like, so as a part of Redpoint Security, we do application security, excuse me? Yeah. Yeah, exactly. It's a Dolphin 1, right? Like, no, it's 2-1-2-1-2-1. Yeah. But we still see this on a daily basis, right? Like, if you haven't seen the Jimmy Kimmel bit where he goes out onto Hollywood and asks people what their password is, right? Go look that up on YouTube. It's amazing what people will tell you if you put them in front of a camera for a little bit of, fame, right? Online fame or whatever it is. But it's fairly easy to crack still. And we still see breaches consistently. In my, day job as someone that looks at applications, does pen testing against applications, we find default accounts almost on a daily basis. We're able to brute force passwords. The credential breaches are still out there. Now, that doesn't mean that there aren't systems large organizations that have fixed this problem, but there's so many applications online nowadays that there is a majority of them that are still struggling with this problem. And authentication is hard, right? Like, we want to be usable. We want people to remember how to log into our system, but we still struggle with it. And, so here's an example. Like, this is from a recent test that we did. This was an invite system where or an invite application, right? So administrator would send you a username and a password. You would log in and you would reset it the first time. This registration flow included these messages that are being sent back out, right? Like, so SLAW, that's me, obviously, 6 test, and I put in a password, and, the first time I have to reset the password, that's great. Like, so it's a unique for whatever it is. It says I've already registered my digital identity, but what is the problem here? The second one says user ID and password you entered doesn't match any entries that I currently have in the system. Now, this isn't the login page. This is the registration flow. So basically, they're confirming to me whether or not my username and password is correct during the registration flow, as opposed to just allowing me to log into the application. And this is very easy to automate. There's no brute force against this. The login page had brute force protection, and it would, if I tried 10 times here, it would not lock me out, but 10 times on the login page, and it would. So, what I'm getting at here is, we recognize that there are threats. Like this company had recognized that there was a threat on this login page, but didn't realize that they had opened up another weakness on yet another channel that existed. Very similar probably to the parent link system, that voicemail system. Like I'm fairly certain the secretaries didn't use the online system to do anything other than, maybe reset the announcements for the day. They didn't realize that there was an interface there where this problem existed. And it allowed for the brute force and the password guessing to go on again and again and again. So I had similar to this, that I'm showing on the other side too. Very easy to do, very easy to automate. It would probably took us longer to figure out that 4-digit passcode than it did for me to crack some identities on this system because of the automation that's available and the tools that are available nowadays. Cool. All right, so let's move forward. This is about a year, 2 years later. We had this date marked in our minds, January 1st, 1993. And again, this is back in the fracking days of the Captain Crunch, making free phone calls. But the little Logan, Utah, where I grew up, January 1st, 1993 was a red letter day for me and my friends. And it's because of star 69. Does anybody remember what star 69 represents? Yes. What is it? Yeah, it's the callback system, right? Like call back the last number. Now, why would that be concerning? Considering what I did previously, why would that be concerning? It's because we were running something like this constantly. This is iWar. Everybody remember the war dialing days? Yes. Finding systems, finding other voicemail boxes, finding, exchanges, what the salespeople would use to make long distance calls, accesses to the ARPANET or the local internet at that time, which was, or BBSs, right? Like this was super fun for us to do. We'd log in and play Trade Wars or Global War 2002. Anyway, so I kind of feel bad now that I think about it, because we would just completely scan the local network using something like iWar to find these different systems. But of course, I'm not doing that during the day because my parents would know if the phone was constantly dialing out. So I would start these dialers at 10 p.m. at night after everybody went to bed and run it. And I'm like, crap, we're just dialing like the entire city's phone space over and over and over at the middle of the night, and it was just ringing random numbers, but they couldn't actually call us back. Right? I mean, it's okay. Like our friends, we'd put their numbers in there because we already knew that they weren't actual systems. But yeah, it's an enumeration attack, right? Like we see this quite often. Again, playing more global wars or trade wars. We'd find sysop panels. We'd get into arguments with people that were running little BBSs in their basement. They're like, "How did you connect to us?" And we're like, you're just online. Again, you're giving this information out. But there was a lot of interesting things that we could identify and start to connect to, start to enumerate, just based on this, the system that was out there. And it was fairly easy to do. But again, star 69 killed that for us, because we knew at that point we would be responsible, or they could actually find out who it was, which was not going to go well. So what does this equate to nowadays? Forced browsing, right? War dialing or an enumeration attack. This is similar to what we would call forced browsing nowadays. I mean, how quickly are you scanned when you put a new system up on the internet? Yeah, I would say if it takes more than 10 minutes for you to actually, like, someone try to connect to SSH and log in, or, that that's actually surprising to me, right? This is an ongoing problem. And often, we're looking for things like, hey, we already know that there's something that's exploitable that's there, like a long distance call service. If we can find something that's interesting, it's going to be attacked. It's all about not being like the low hanging fruit when it comes down to it, if we are rolling something new that's out. Other vulnerabilities that we see on a daily basis, probably 90% of the applications that we look at, either from a code or a pen testing perspective, have some sort of an access control flaw. Right. Specifically, right, like insecure direct object reference, or this like missing function level access control, that we're able to actually get information out or do something that was unintended because the developers forgot that there's a framework and an endpoint that exists, or they rolled out a default, whatever, right? Like, it's really this idea of security through obscurity that they are depending on that isn't necessarily any security at all when it comes down to it. Failure to restrict URL access. So we're seeing this quite often, right? It's just driving around that gate because the gate doesn't really do anything. So this was a recent example, right? This company had rolled out a new application. It was a multi-tenant application, and they thought, wow, we need to really keep this company data abstracted apart from each other, right? Like, we have all of these like clients that are coming in. So we're going to give them their own URL, but we're only going to we're going to make it easy for them to remember. So we're only going to just give them a 3-letter path to actually get into this, their data as opposed to someone else's data. Part of the problem was they didn't have any real authorization controls outside of this 3-letter code that they popped in there. And if you had logged into the system, if you just accessed one of the other URLs, you could see like the configuration data, including things like secret keys and other stuff that was being used by their application to make security decisions and generate security tokens from this configuration in and of itself. So all we had to do, like 26 characters, again, like it's all lowercase as it is, right? All we had to do was run through these different items, and all of a sudden, this was in a staging environment in production. We probably would have got a hit of about 20 to 30 different clients that they had in there. But in staging, right, like 1, 2, 3, 4, like cat, CCC, dev, nel, all returned relevant information. And again, it's an enumeration attack. Very easy to do. Automated systems make it very quick. This was a lot faster than scanning a POTS network, where I'm scanning tens of thousands of numbers. I guess there is 18,000 numbers I'm running through, but the internet's a lot faster than that phone network for sure. Okay, so let's move forward a little bit further. I said I worked at iOmega. July 15th, 2001. Does anyone remember what the big security issues that were happening back in the early 2000s were? Okay, that's a zip disk for those of you that aren't sure, right? Have never seen one before. Yeah, I do have a couple of them floating around still. But does anybody remember Code Red? Yes. Those were good days, right? So I had moved it to iOmega. I graduated from school at this point, and iOmega was really an early startup, an early tech provider, right? You think about the original zip disk, and even the Bernoulli drive, if anybody dealt with those. That was, in the 90s. But so they were early into jumping onto the internet, which is great, right? They were trying to get ahead of the game. They had applied for IP addresses as soon as they could, and they'd been given a full Class B network, right? Which is great. The problem was that in their infinite wisdom, they're just like, oh, we have, all of these IP addresses that we can assign and that we can give out. So what are we going to do? We're going to put our whole company infrastructure, including developer systems and manufacturing systems. They're all going to get routable IP addresses, and they're just going to be online all the time because it makes it really easy to administrate and actually do things. Now, Code Red is a worm, right? It's a Trojan that went around, or it's a worm, I should say, and actually looked for open ports and then would replicate itself by, spinning through the local network. As soon as one item was infected, it would spider out from there pretty easily over, I think it was port 1433 or 34, right? As it was looking for other vulnerable instances of Windows instances that existed. Code Red hit iOmega because it was publicly accessible, easy to actually find, and all of the manufacturing systems were running vulnerable versions of Windows. And it took it down, I think, for a week, like the whole pipeline, because they had decided to just put everything out on the internet and not necessarily thought about protection or thought about restricting access. Again, I mean, we're talking enumeration, but realistically, it's just this, the ability to put that, or to make it available, to make it easy to use. So what was their solution, right? Obviously, you got to go patch the systems. You got to reinstall, refresh. They had a hard time actually fixing this because every time they'd stand up a new box, it was vulnerable and it would get hit before, they just didn't have anything in place to prevent it. So this got me into security, right? This was a portion of it because at the time I was just doing like kind of web development work, early web development work for them. And we had to actually track this down and help them put firewalls in place and figure out, okay, like it's not only the Windows and the engineering systems we got to protect, it's everything. It's all the developer workstations. It's also like all the web systems. And so they came up with this. They're like, yeah, we're going to put a firewall in place, right? Like it paid for them to actually put a security team in place and start to think about security in a real way, as opposed to, hey, we're just gonna open everything up and make it for ease of use. This kind of led me to this graph here about security tools in general, right? And we still do this today from an application security or a security perspective. Like we go talk to a vendor, we go look at Gartner, and we're like, wow, there is this new security feature, the security tool that's going to solve all of my problems, right? There's a technology trigger that hits. Like nowadays, we're right in the middle of this AI hype cycle, right? Like AI is going to solve everything and it's going to be amazing and it's going to find all the security vulnerabilities. We're never going to have to worry about it again. I mean, how many AI talks were there this week, right? Like a few, right? And rightfully so, because it is innovative technology that's going to change the space. But our expectations have to be tempered a little bit, right? We come in with these inflated expectations that AI is going to solve all of our security problems, or a firewall, or whatever it is. And then once we start to implement it, we go through this trough of disillusionment, right? Like we're going to go up and say, yes, this is great. We're going to sign up and give these vendors money to solve this problem. And then we realize there's still got to be a human in the mix. I've seen this happen so many times in the space, right? Like WAFs, like web application firewalls at iOmega, WAFs at a bank that I worked at. Oh, it's going to solve our application security problems. Oh, wait, no, never mind. We're going to buy a dynamic scanner and that's going to find all the vulnerabilities, solve the problems. No, it's going to be static analysis. It's going to be an SCA tool. Now it's going to be an AI system that consumes all of these reports. But there's always going to have to be a person involved. And that's where this slope of enlightenment comes into play. Like somebody's actually going to have to take those results, implement them, and put them into place. And that's where that plateau of productivity exists, right? So the firewall results that we had, or the firewall we put in place at iOmega, it did a good job, but it didn't necessarily solve the problem because the problem was already inside the walls, right? And so it took longer to resolve because of that, the issue that existed and how it existed. So we've just got to take everything with a grain of salt is what that one boils down to. Okay, so let's move forward a few years. This was just, April 25th, 2021. We are in the midst of a pandemic, right? Starting to come out of it. Everyone's been at home for, 18 months or a good couple of years at this point. We're all looking to get out, right? So everybody's going out and spending money on experiences and other things. Of course, I'm from Salt Lake City. On April 25th, this is when Disney decided to create their new magic key. So their new season passes. We're like, okay, this is great. We've got a couple of kids. One's, younger. This is kind of right up his alley. We can go we can go for a couple of times over the year and it'll work out for us. Right. But there was huge demand for these season passes, for these magic keys, to the point that, you would log into the system. You're trying to actually, buy one of these passes, and you would end up on a page that looked like this on the left here, right? Thank you for your continued patience. We're trying to clear all of these orders. All right, we're going to have to wait, like approximate wait time. It's more than an hour, and it just keeps spinning there. So I'm sitting there waiting, and I'm like, man, this is taking a long time. So I open it up and I start running through my request through Burp. And here I'll show you. And this is the response that I was getting, right? Is it was just querying every minute or so. You'll see there's a last updated UTC. So there's a time there. Like this was the last time it made a request that just came back, August 25th at 9:28, or 21:28 in military time, right? But, it said more than an hour on the screen, and it says like, it's 90% of the way there. We're almost there. But you look at the expected service time here. I'm pretty sure this is more than 12 hours later. I really don't want to sit that long, right? Like, I mean, I love my kids and all, but damn, right? Like 12 hours to just buy a season pass, that's untenable. But then I got to thinking, I'm like, I'm not the only one stuck on this screen, right? There's got to be, at least a couple thousand people that are sitting there waiting to be serviced. So I dig a little deeper and just look at what's available to me. And it says, do not refresh the page, approximate wait time more than an hour. But at the very bottom there, it says QID. All right. In Burp, QID is just one of the cookies that's being sent over and over. And it's telling me like, oh, you have more than an hour. Okay, so they've got like some sort of a waiting system that they've created here. Queues, which means there's more than one person in each queue, right? And that's just when you can actually buy tickets so that the system doesn't get overloaded. But it is on the screen in front of everyone's face. So what do people do that are sitting around and waiting and are bored and frustrated? Yeah. They go online and they complain about it. And not only that, they post images of what they're seeing on Twitter. So honestly, I went on Twitter, did a search for hashtag magic key. And some people are like, oh, look, does it show like this or no? No, this is what I'm seeing. And found multiple instances where people were taking screenshots with their iPhones or whatever, with their phones of the wait screen that they were on. And then, of course, it included the QID right down at the bottom. I was like, hey, this is great. Like, let's see if I can find a queue that I can actually service quicker and I can be done with this and move on with my life. Yeah, 9 minutes later, I was able to buy tickets, right? And okay, so at the time, the reason I have this one so well documented is we actually had a friend that was working on the security architecture team at Disney at the time. And so I like put this all in an email and I was like, here, man, like realistically, you got to do something here, right? Like, this is, granted, like I still paid for the passes. I'm not a monster, right? Like but at the same time, right? Like this is just, we didn't think about what we were exposing, sensitive data disclosure, right? On this screen when we showed it to people. And if you do one thing, just remove that QID from the page, right? If somebody needs that information, they'll be able to look it up, or you put like help and that's when they show, and that's when this actually gets shared across. But we don't want to, trust the client with sensitive values. Again, we can just manipulate something that we have. We can send it to the server. You should encrypt and sign and all, validate things that are coming from a user. I was already signed in at this point as well. So there was no real reason for you to do this. You can do the lookup on the back end based on the session object. And so, I mean, there's a lot that goes into it. This isn't the most severe vulnerability, but it's one of the most fun that I've had with, as far as like being public and being online, because it's fairly easy to take advantage of and people understand. So, okay. So why do these issues still exist, right? Like, obviously, like, we've had a lot of smart people thinking about security since 1970 and probably even before. I mean, they're the ones that came up with the initial secure architectures. You talk about Ring 0. You talk about like CPU protections that have been built into systems for years and years. So why do these issues still exist, right? It's not every organization where we see it. But part of the problem is security has always been a point solution and an afterthought, especially from a commercial business perspective. You think about the DoD networks, like you've got CypherNet and like the secure nets that are out there where, they process sensitive information and they do it in an incredibly secure manner. So we can do that, but it does decrease innovation and it makes it harder to innovate in the space that we're in nowadays. And so we've come up with this idea, security is kind of a point solution. It's an afterthought. Like we measure security based on like very specific endpoints. And then we move on, we innovate, we adopt the latest technology. We start using things before there are security controls in place for it. That's the reason we're having so many discussions about AI right now, is there's not a lot of security controls that exist with it, right? But it all goes back to this, like, hey, security is a design problem, right? We're not educating developers on how to secure things at a proper time. How many of you have taken a security course in the past, right? A developer security course. Sweet. Okay, good. But realistically, how effective was that? Did it change your daily activity? Yeah, exactly. I see some thumbs going down. Yeah, maybe some, right? Security teaching is inefficient. Granted, I went to school a long time ago, but my first computer security course, and this was coming from the CS department, it talked about like how you implement like cryptographic algorithms, right? And we're talking about S boxes and, how like triple DES was put together. AES was up and coming at the time. And I'm like, yeah, this is cool, but I'm really not I love math, but I'm not a math geek. And you really want me implementing this as, somebody straight out of school. This is not really what is affecting security. Yes, it does, like at some level there's exploits against, cryptographic algorithms, but on a daily basis, that's not necessarily what we're seeing. So we're not teaching it very well. The recommendations in this case, right? Like it's way too specific or it's way too generic, right? We're not meeting the developers where they need to be met. And then there's conflicting advice. AI sounds really, really confident about like what security controls should be in place, but man, go ask it about just like SQL injection, like ChatGPT, right? Like SQL injection and solving that in a Rails framework, and it'll give you some advice, but whether or not it actually is applicable to what you want to do is one thing. And apparently ChatGPT, no, never mind. Sorry, that's a missed thing there. But Stack Overflow is also a mixed bag. But we have trained AI systems on available information that's on the internet, and 90% of what is on Stack Overflow is probably not correct when it comes to security. And then what works in one language doesn't apply in the next, or it doesn't always apply in the next one. And so like we're struggling there. Like again, this is a design problem. Developers are designing systems without security knowledge, so we've got to meet them in some way. And then, if your employer or your, company doesn't take security seriously, why should you? They don't give you time to actually do this. It's a problem. Most organizations that we walk into, security, again, is an afterthought. We do a pen test report. We find some flaws and we come back the next year and we find the same flaws, right? They just they're not given the time to actually fix it. So we've turned to security tools to change this. But again, tools are often wrong. They don't work in the development environment the developers are using. It's not the right language. It's not the right IDE, whatever it is. Identification does not equal remediation. Has anybody dealt with reports from SaaS tools like Checkmarks or Fortify in the past? Yeah. How many of those do you get in a single report? Tens, 20s. Yeah, 10, 20,000 is pretty standard in my. Yeah, just turn that over to a developer and see how fast they really want to jump on something that's going to just increase their workload from, 40 hours a week to 60 hours a week just to track down false positives, right? There's no magic bullet, right? Whether you're working in operations, development, QA, they want a magic bullet. It's hard, right? Like security is hard. You're never going to get away from that. And then finally, right, security support is always difficult. We do a poor job of explaining why, what, and how, like what remediation should actually look like. Again, meeting the developers where they're at. First interactions with security are usually negative, right? I remember this as a developer, you've created some new system, some new application, and the first thing you get told by security is, no, you can't actually do that, right? Like the business wants it, but I'm not allowed to do it. There's this weird relationship that security and development have. Now we're getting better because we have things like product security and application security engineers that come up from a coding background. But these interactions are usually negative. So like the developers gets handed a huge code base from 2010 or whatever it is, and it's vulnerable to SQL injection. Oh no, like why haven't you fixed this? And they're like, I don't even know, like this is written in Cold Fusion and I'm a JavaScript of the developer. What do you want from me, right? Like it's very difficult to have a good security discussion and a relationship between security and development when it's antagonistic. So this goes back to, providing satisfactory security controls in a computer system is in itself a design problem. So I'm saying it again so that, you can remember to talk to your developers. But, all hope is not lost, right? Good things are happening. We are getting better. We're trending more towards evaluating systems like in the Ware report, like what is being recommended there. We're doing things like threat modeling. 10 years ago, if you had asked me about threat modeling, there was just nothing available. Yes, Microsoft had done some research at that point, but the companies were not digging in at that level, right? They just weren't thinking about all of the threats to an application and how to push left, how to build security in. I mean, 10 to 15 years ago, I had never even heard the term product security, like this idea that you have a engineering organization that is building security tools specific to your organization and specific to your application, right? Netflix was really the first big organization that approached it in that manner. Yes, you always had your like IBMs and Microsofts that had something that was similar to that, like building security tools for their products, but it has become it's become widespread and adopted at this point. And then this term of DevSecOps as well. Yes, we have these tools available to us. Why don't we run them on a daily basis, on a push basis, and actually start to identify and reduce that over time? I mean, Fortify, the static analysis tools, they're generating, tens of thousands of vulnerabilities. Hey, maybe we just do a diff and we check to see, did we add to that number in this build or did it actually reduce? And that is the signal we start to use so that the developers get some sort of a better feel for what security should be, and we see reduction over time. But what can you do, right? Like in your organization, in your experience or in your role, security, yes, we want it to be a point solution and we want it to be easy, but realistically, it's about the relationships that you have as a security person and how you build that in. You can train the developers, but you've got to provide support there, right? Like we've got to build those relationships between developers, administrators, management, and be that connection of, hey, security is not necessarily a point solution. It is part of the culture as we build applications. It's just like, hey, we want to build a nice user interface and we want to do testing and make sure it's functional. We just need to make sure it's security functional as well. So really, what can you do? Security is a journey. It's not a destination. It's not a point solution. And we've got to come up with these repeatable processes, right? Approaches that are specific to your organization and goals. What works for Netflix or or Microsoft is not going to work for a startup when you only have one engineer, right? But that engineer still has to be couched in security, still has to be trained in security to be able to address the problems that are going to pop up. Otherwise, they're going to expose that health data that they are handling because they don't know any better and they're trying to move quickly. So security just needs to be embedded across the organization. One of the ways to do this is look for those that support security and are interested in it. So things like security champions programs, if you've heard that term before. But realistically, it is a journey and it's about the relationships that are there. And go read the Ware report. Yes, I know it'll help you sleep on the plane on the way back, but it's a fascinating look at what people people were thinking about and what engineers were thinking about from a security perspective back in the late 60s, early 70s, and why it would be applicable, right? And it is, right? Like access control throughout the system, building out RBAC systems, it's in there, right? File classification, data classification, input validations in it, right? Authentication, authorization. I always talk on the podcast about the Crocs and socks of security, right? So it's like the dad items of security that, most of the developers, like new developers, don't want to think about. My favorite is logging because, we just don't do a good job of auditing, right? And making sure we know what happened in systems, especially modern systems as we're developing so quickly. And then system certifications in there as well. But go give it a read if you've never done that before. It's not super long, but it is, it can be a little difficult, right? Security is hard. Try harder, right? That's my main recommendation there is, we just have to keep at it. Like I have over the course of my career, but keep at it. Cool. Okay. So that's it. Questions, concerns. I mean, we could do a short reading of the WARE report if you want to. I'll drone on for a little bit longer. No. Okay. All right. Well, thank you so much. I do have some Absolute AppSec stickers and actually a pair of socks for Crocs and socks. If anyone would like a pair of socks, I got a couple of them with me. And yeah, otherwise, if you have additional questions, feel free to reach out. I'm at Seth Law on the social medias, right? Or Seth at redpointsecurity.com. But I appreciate everyone coming today. And yeah, hope to see you around the con.